Okay. So again, I am repeating that. So this is, let us say this is be a stock market. Day one, the index is around 300. Day two, the index is around 400. Day three, the index is around 280. Now, what is the index on day four? Right. So basically, based upon the dependent variable is the basically the day. So the basically the stock index value, and you have to find the basically on day four what is the value of the stock index based upon the particular day trends. So that is all about basically regression. Okay. So basically, what is regression? It's a function estimator. It is a function estimator, also called a regressor, is a mapping from f of x to r. Okay, the regression learning problem is to learn a function estimator for from example x of I to f of x of I. This you understood? এটা সবাই বুঝতে পেরেছো? A function estimator, also called a regressor, is a mapping from f of x to r. The regression learning problem is to learn a function estimator from example. So basically, you have to estimate the stock market based upon the particular day in this. So it may also happen that you want to find the particular day values on that particular value. So based upon these values, you can find these things. So the regression learning problem is to learn a function estimator from example x of I to, and you have to basically estimate what is the stock index based upon the x of I. So x of I in this case is the day, and f of x of I is basically the stock value based upon the particular day. এটা বুঝতে পেরেছো? কেউ বুঝতে পারো না, কেউ যদি না বুঝতে পারো তাহলে আমাকে জিজ্ঞেস করতে পারো। হ্যালো হ্যালো হ্যালো, এই সবাই বুঝতে পেরেছো? Okay, fine. Shreyoshi understood? Sudeep understood? Okay, fine. Now let us go into the other part. So now let us say these are the trends of that particular day, right? Now these are the trends of a particular day. Day one, the trend is this much one. Day two, the trend is around two. Day four, the trend is around this one. Day six, the trend is around this dot, and day eight, this trend is around it. Okay. Now this function can be basically linear, or it can be also a non-linear function. So based upon the degrees, if it is a degree 1, then it's a straight line. That is this one. It goes into like this straight line that looks like this one right hand side. Degree 2 is a parabola. Okay. Degree 3 is, and degree 4 is the lowest degree able to fit the points exactly. And lastly is the degree 5, which basically exactly matches all the points. Okay. So basically, let us say if the actual value of the stock is like this. Okay, so let us say this is the actual value. Okay, and your predicted is around this much. Okay, so this is the particular error, but you can see that it generally follows the trend of the day indexes. Okay, so let us say this is the predicted এক সেকেন্ড। No, no. Okay, so this is the predicted value. And this is the actual. Okay, now what is the actual? You see that is there is a particular trend. Okay, now in this case, you can say there is a little bit of error of this much percentage. Okay, so what is a regression? Basically, it's a function estimator, also called mapping from f of x to r. The regression learning problem is to learn a function estimator from examples. Okay, so polynomials of different degrees are fitted to a 5 points. So this is a degree 1, degree 2, degree 3, degree 4, degree 5. And if there is a piecewise constant function learned from the grouping model, the dotted reference line is the linear function from the left. So basically, you have to fit a particular line to this particular trends. Okay. Now let us go to this one. What is overfitting? Now, an n degree polynomial has n plus 1 parameter. N degree polynomial has n plus 1 parameter. See, this is a straight line formula. Y equal to ax plus b. What are the two parameters in here? A and b. So it's a n degree polynomial, that is x degree is 1, and it has n plus 1 polynomial, that it has two parameters, that is 1 plus 1, 2 parameters. So that means the polynomial of degree 4 can fit 5 points exactly, that is 5 parameters. So you are understanding, so if there are 5 points, so a degree polynomial of degree 4 can fit all the 5 points. So if there are 2 points, a straight line can fit all the 2 parameters. So to avoid overfitting, the number of parameters estimated from the data must be considerably less than the number of data points. Okay, so we have to prevent overfitting. We do not want that a particular line fits all the points. Why it is not required? Because it may create a error, testing error. That's why we try to prevent overfitting. So what is a loss function? Regression models are evaluated by applying a loss function to the residuals fx minus f bar x. Unlike classification loss functions, the regression loss functions will typically be symmetric around 0. Okay. So basically, when you are loss function, so basically you are talking about loss function. So this is the loss. So this is the difference between the actual and predicted. So this you can call as the loss. Okay. So but there are different kinds of how to compute the loss function. So one is you just subtract the actual and predicted. That is one way of to compute the loss function. Okay. So the most common is the squared residual. Squared residuals means f of x minus f of x bar whole square is called the squared residual loss function. In here we come an important problem that is called the bias and variance dilemma. Bias is error. Variance is how much the output is varies from the actual output, right? How much the predicted differs from the actual. Bias is basically actual minus predicted. Variance is how much it varies. So let us understand from this formula. So this is called low bias and this is called low variance. High variance means they all are basically, this is low bias and this is high variance, this formula one. Okay, this is high variance and low bias. This is high bias and low variance. Okay, high bias and low variance means the error is very high. Error basically diverts from the what you can say diverts from the actual path by very much, but the variance is between the predicted variables is low. So you see these are predicted variables and the difference between them is pretty low. And this situation must be totally avoided, that is high bias and high variance. So this situation is the ideal situation, low variance and low bias. High variance cannot be sometimes avoided, and sometimes basically high bias and low variance cannot be also avoided. But this situation and this situation, but this is the ideal situation in here. Okay, so in here we can compute like this one, that if we underestimate the number of parameters of the model, we will not be able to decrease. One second. One second. Okay, sorry about that. So if you underestimate the number of parameters of them, we will not be able to decrease the loss to zero regardless of how much training data we have. Okay. So that is one of the issues. On the other hand, with a large number of parameters, the model will not be able to be dependent on training sample. The small variations in the training can result in a considerably different model. So you see, this is very simple model can lead to basically high bias, but basically a very complicated model also can lead to a very high variations. That is what you can call as the bias variance dilemma. That is, it is dependent upon the total number of parameters. So the expected squared prediction error at point x is error x e y, that is the actual minus the predicted whole square, that is the squared function. So it is decomposed into bias and variance component, right? So this is the bias squared f of x minus f of x bar whole square, plus this is the variance f of x minus expected value. What do you mean by the expected value? Expected value means the mean value, and sigma is the basically the irreducible error or the noise. Okay. So a low complexity model suffers less from variability due to random variation training data, but may introduce systematic. So a low complexity model, that you can say a low degree model, that is a straight line model, suffers from less variance, but but less variance, but there can be high bias. But a high complexity model is basically a highly non-linear model. It's eliminates the bias but suffers from non-systematic errors due to the variance. Okay, this you understood? আচ্ছা, এই ক্লাসটা বুঝতে পেরেছো? হ্যালো, আমি রিপিট করে দিচ্ছি। So this is regression. In regression, we basically predict a value which is depending upon another values. So basically, in here, this is a stock market index of say Tata Motors. On day one, it is this much. Day two is this much. Day three is this much. But on day four, how much it is you have to predict based upon your machine learning model. In here, the regression models comes into place. So it is basically a function estimator. This is very important point, right? So you have to predict the function from this estimate. And so basically these are the some of the points which have been predicted, and your polynomial should fit all these lines, right? And what is overfitting? If your model fits all the lines, it is called overfitting. But overfitting is not desired basically because it results in high testing error. So in this case, the straight line has 2 parameters and polynomial degree 4, 5 parameters. So avoid overfitting, the number of parameters estimated data must be considered less than the number of data points. What is loss function? Actual minus predicted. So basically it should be symmetric around 0. And the most common choice is to take squared residual as the loss function. What is bias variance formula? So basically a low complexity model results in high bias but low variance. But in a, what we can say, a high complex model suffers from non-system, eliminates the bias but suffers from high variance, right? এটা বুঝতে পেরেছো? আচ্ছা, এইটা তোমরা পড়ো, আমি বিকেলবেলার দিকে তোমাদের অ্যাসাইনমেন্ট পাঠাচ্ছি। ঠিক আছে, just give your roll numbers now. আচ্ছা, তোমাদের রোল নাম্বারটা দিয়ে দাও, আমি তোমাদের অ্যাসাইনমেন্টটা কিছুক্ষণের মধ্যে পাঠিয়ে দিচ্ছি, হয়তো বিকেলবেলা টাইম লাগবে। Okay, I'm leaving the call.